Okay, yeah.
Okay. So there is this text file in our repository. Maybe I can show where it is. Like this. So this is our repository, and the file we will be working with is under the notebooks folder, and inside that is the data folder. So data folder Riga Wikipedia.txt. So some text about Riga. If you have downloaded this repository to your computer, so this is for users of Anaconda, then reading this file is as simple as first. Okay, I have to run the notebook. As simple as saying open file name. So first we open the file name. This gives us the open file object, and then we can call a read method on that object. So when I execute this command, I see that something must be wrong. It does not work. So it will work fine if you are using Anaconda, because on Anaconda you have this file located in the data subdirectory of the notebook directory. But what if you are using Google Colab? In that case, the file is not there. You have a files icon which you can click and see what files are available to you, and you see that there is no data directory here. Okay. But we have accounted for this case, so this action will not fail on Google Colab. But what you can do instead is read this file directly from GitHub. So I showed you that this file is available at GitHub. Here we can copy a link to the raw text. So raw text of the file. And so in Google Colab you have just a small task to do. You have to uncomment the commented bit of code. So you have to uncomment this next cell. And what we do in this cell is first we import the libraries that we will be using. So libraries are kind of a package that contains some useful functionality. We did not look at them in the previous part, but they come in naturally here, that when we want, for example, to read some content from the web, we may want to use the library called requests. Requests is a library for reading content from the web. So we say import requests. We define a variable for the URL that we want to read, and then we say request.get URL. So get content from this web address. Web address rigawikipedia.txt. And finally, we are interested in the text sent to us in response. So that's the data. Data will be the result of this web request. And we can look at what the data contains. And here is some text that is now in our data variable. So we can work with that data variable. For example, we can print the first 100 characters of this file.
I have a question for you, Ulis. I wonder, those who are using Anaconda, are you seeing the diacritics? Are you seeing the full Latvian letters in, or are you go up to your example, the one for Anaconda. This works for web data. But how about the file? Because we had an error. But those who are using Anaconda directly reading file, are you able to read the file? No? Right.
No, it doesn't work for you. There is a comment in the Zoom stream from Tula.
That's what I wanted. That's why. Yeah, exactly. That's why I was asking this thing. So Tula from Estonia, I believe, right? That yes, encoding. So this is when if you're opening the file if you're opening a non-English file, meaning file which contains non-ASCII characters, you need to specify encoding. Yeah, this. R is of course not required, but it's okay. So encoding equals UTF-8. Right, that's what the tool is showing. So this is for those who are opening, you're opening the dash between A, I believe it's between F. I usually use it. Yeah. So basically what it says that the file has is encoded as UTF-8. If you're opening from a web, it seems to work with request library. All the work is done for you. The encoding Finland. Okay. Great. Tula. So then your file will be read and decoded properly. It's one of those things you encounter often. So could be a question why is not encoding UTF-8 not default anymore? Because everybody's using Unicode these days, right? So but this is basically you will reading files. You will need to specify this for text files. Right. For text files which have non-English characters. So this applies to pretty much all the languages. Right. So okay.
Okay. Thank you. And thanks to Tula for this valuable comment. So if you are using Anaconda, so local installations, then indeed you need to specify the encoding. So file name was not correct.
It should exist on your computer. Yes. So this means where your notebooks are, there should be a subfolder with the data. That if it's not there, it won't open.
Well, maybe it's something with Windows out, but this is Windows 2.
Yeah.
And it works. Okay.
We were using Visual Studio Code.
Yeah.
Okay. It works. Okay. Very good. Thank you. Okay, so there is a version for the local installation with this code snippet here, and a version for people using Google Colab.
So all this, if I understand correctly, this would work for pretty much any text page URL which has a text file. Basically, it would download the text file and you would get the text file as a data, basically.
Indeed, that's how we can read any text file from the web. So that's a nice thing to be able to do. And that is thanks to the request library. If you wanted to learn more about this library, then you can look on Google for Python requests, for example. Requests. And requests HTTP for humans. So this is the library that we are using, and their example also shows request.get method, and then you can ask for the text as well.
I think this will be very useful in another workshop in 2 days by Maria, who is dealing with web scraping. The other workshop, this will be used, I'm sure, there.
Okay. Yes. All right. And then we can do some things with the data that we received. And by the way, if for someone, if there are still issues, if this example did not work for you, then let us know. And one of us will approach you and try to help you. So if it didn't work, it didn't work for you, right?
let me fix it.
Okay, well, this will go and help. All right. And you already saw the use of the split method. So we can use split method to split the text into tokens or words in this case. So let's execute this cell. And let's look at the contents of this words variable. So the words variable has all the words, all the tokens in this text. We can count the length, the number of words that we have in this case, and that's 257 words. Or we can use slicing to show, for example, the first 50 words that we have read. So basically you have in this example, you will have read a text file and done some basic operations like counting the number of words and printing some of the words. What else could we do with this content? We could count word frequency. And for that, we may use, well, we could jump into an NLTK library, but that's for tomorrow. For today, for counting the number of words, we can use Python's built-in libraries. And one of these libraries is called collections, and this collections library contains the counter object, which helps us count various things. For example, I will show a simple example with, for example, my name is okay. I will write full name here. My name is Boyars. And let's count the number of letters in my name. So I launch this counter object and give it as a parameter my name variable. So that will be the object that I will be counting. And you can see that this counter worked and determines the frequency of letters in my name in this case. So there is one space, one capital B, capital U, and two letters S. And the same way you can use this counter object on the words that you got from the text loaded from a file or the web. So we say that the C variable contains the result of counting words in this list. So that's a list of words. We run counter, and now we can use the method of counter called most common, which will return the 20 most common words in this text. And here are the most popular words. Okay. That's because the counter is getting different types of input. In case of counting letters, the type of my name is a string. So that is string input. But the type of words is a list. And so it counts the number of items in a list. So it's different data types. If I wanted to count words in my name, not letters, then I would want to make a list that consists of two items, oldest and boyars. Which I could get, for example, by using split. Alright, so we have got count of words, and the most popular words are maybe not the most interesting ones, but they are the, of, is, and followed by Riga. That's already more interesting word. We can use a for cycle to print these most common words in a more nicer way. So for token and count in C most common. So you can see how I am specifying that I want to split this result into token and token count. And then let's print the name of the token, the text, and how many times it appears. Let's run it. And here is a nicer way where we can see that Riga is popular, but there are also 5 times occurrence of words Baltic and European. So that was word counting. You should notice that some words appear in both lowercase and uppercase. For example, the. We may want to do some data cleanup, some data normalization before we do this analysis of text. Let me know if you have anything to add about that.
Yes, definitely. Usually, the usual workflow would be to normalize text beforehand, meaning you would lowercase or uppercase or maybe title or capitalize all the tokens on because of course the capitalized or non-capitalized, they have the same meaning. So that's the usual use case, right? So yeah, very completely agree with all this. Yeah.
Okay. And next, let's read comma-separated values or tab-separated values types. Files. So again, let's look at the GitHub repository. And this repository has a directory called corpora, which contains text corpora in 3 languages. So Estonian, Latvian, and Ukrainian. And there is also, for Latvian, there is a subset of 5,000 records, so just a smaller set of results, like a smaller file that we can work with. So this is what this file looks like. It might be small text, but well, basically, let's look at it from the Google Column side. But the columns in this file, so you can look at this file as a table which has 4 columns. Language, for example, Latvian, source, for example, DNLV or day.lv, date, and text. So this is text with some metadata, like date, source, and language. And we will work with that file. The file consists of rows that contain values, in this case 4 columns, separated by special character called tab character. That's why it's called tab-separated values file. And we will use the Pandas library to work with this file. So this here is the direct URL to the Latvian corpus subset. So first we need to import, to use this Pandas library, we need to import it. So let's do that. And now we again are at the moment when some things will not work in Google Colab and some things will not work in Anaconda. So let's try to do this. So file name, we define where that file is located, and then we use the pandas.read CSV method to read the file from this file name, from this path, and we tell it to use the tab character, this one here, as a separator. Let's run it, and this action will work for people using local, should work for people using the local installation, and you can go further with the rest of this notebook. But for people using Google Colab, this action will fail. And there are two approaches what you can take. You can either upload the file to Google Colab, but you have to keep in mind that this is temporary, that Google Colab will shut down the machine in half an hour or so of inactivity. And then you can read this file just as if it were on your local computer. And let's try that. So we need to upload the file. But first, since your computer,
I'll show you where it is. So, well, we can just go here. So, right, we want to upload. We could make a separate folder called corpora or data, but we'll just upload directly to this folder here. So, we click on upload. Right, and we need to find it, right? So, we'll need to find our notebook. I have a huge GitHub folder. And we have our Baltic, right? We have here name. Where's my Baltic? Baltic, right? Corpora, I believe, right? Yes. On this file here, right? You actually I think you can upload multiple files too if you want. So open, right? On reminder, upload the files will get deleted when this runtime is recycled. Okay. So let's wait. It should be uploaded, but I think you need to refresh, I believe, right? You want to see? I mean, it's not. You do see. Okay, so it's here. So it should work. Now let's try this. Let's try. And all this stuff that I want to maybe artists can show the third approach as well. This Google Drive.
Okay. So now the file should be accessible in the current directory. Okay, there is a question. Maybe you can take a look. This is the first approach of uploading to Google Colab. So the file should be in this location, so file name at the current directory, and let's try to read it.
Yes.
Yay, we have the file. That's one of the options for Google Colab. We read the file here with read CSV. And then we store the resulting data set as DF. So well, there's a question as well.
Pandas, does Pandas have a module we need to download somewhere?
It should be available. It should be installed by default on Colab and also on a home installation. You have completely
Okay. So there's some tech help session now on. But basically, here in this Google Colab notebook, this first approach worked okay. So we read the file, and then with the head method, we displayed the first 5 records of this file. So you can see that it's displayed as a table having 5 rows and 4 columns: language, source, date, and text. Let's see what other approach we could have taken. The second approach would be to read this file directly from GitHub. So just as we did for the text file before. So we define the URL, the web address from which we will read that file. And then we use Pandas read CSV method. But in this case, we don't use a file name, we use a web address from which we will read this data. So the second approach is reading data from the web. Let's try it. And this approach worked as well. So you can see that we stored the result in the variable df2. It's short for data frame 2. And with the head method, we can look at the head, so at the first 5 rows of this file. We could specify a different number of rows to show. For example, the f head 20 will show the first 20 lines. You may also want to know how to read data from a subfolder in Colab, so data that is not in the current directory. For example, here we have a subfolder sample data, which contains file readme.md.markdown. And we can do that as well. So we just have to specify the path to the file. So sample data directory and the name of the file in the directory.
So obviously this will not work on your local Anaconda if you don't have a sample data folder, right? You don't have it, so...
Yes, so this example is not for those who are using a local installation because you don't have this file here. But for Google Colab, we can run this example, and here is the text that has been read from this readme.md file. But basically it's the same as reading a file as you saw already at the first start of the notebook. Did you want to show this Google Drive approach as well?
Or not? Artists, we can try this. I don't know, artists is more familiar. Could artists join us? There's a third approach for very convenient. That if you want to, you have a Google Drive, everybody gets a Google Drive account, right, if you have Google. So yeah, this one here, you click on it, mount, on, so this cell, you run into cell, yeah, dismiss, right, and so basically run this, right, import drive to this simple cell, run it, let's run it, on, yeah, you have to, of course, yeah, connect to Google Drive. Right. So of course we'll use, let's say we can use this one. So you can use your Google. It's quite convenient because then you can save it, right? And you have to give lots of permissions, of course, right? Okay, it's not my main account, so okay, right? And again, it's of course it's Google knows us anyways, right? So, but we'll see. I don't think there's any dirty laundry here, hopefully not, right? So it's mounted here, right? Where is it mounted now? It's content drive. Drive.
Content drive.
So now, okay. So now how do we?
I will refresh this one here.
Yes. Okay. There we go. So now everything is nothing's dirty. Yeah, my drive. Yes. There's actually lots of stuff here actually. Right. So yeah, you see all my some of my work stuff is here, right? So actually, you have of course you won't be able, you will connect to your drive, not mine, right? So everybody gets. So that's quite nice. So let's see if we can get any file here. Let's try Colab notebooks, let's say, or some text file, data, images. What's this one here? Eastern European time. Maybe some data would be nice. Cornell. Yeah, let's say something like this. So let's see. This is where it's in drive, my drive, data, Cornell, and raw script URL. So movie lines. That looks like fun, right? So yeah, let's show this one. So copy paste. I think let's copy paste, right? Copy paste because I don't want to remember all this. So Control V. Okay, that looks like right. So my paste. So movie path, file path, right?
So this way you could upload all your files to Google Drive and then use this Google Drive content from Google Colab.
And you could also save there as well. That's a good part too. Yeah, let me continue then, I guess. So we have. So you need to run this Google Colab import drive if you are on Google Colab. It won't work on local installation because you only have your files locally anyways. So that's my file path, right? I'll check if I. Of course, it's right. Okay. And now let's open up. So, but I will show you all this is showing that if you open a file, text file, using you need to open and you need to close it, right? there's an alternative approach. So viz, using something like this, viz open, right, file path, and I'll do encoding, but again encoding, come on, encoding, come on, not picking up. Right, UTF-8. Again, here of course I assume these movie lines are mostly in English, but just in case, right? As F, basically we open file stream, and let's read the lines. Movie lines, right? Movie lines, movie list maybe, right? It's a list basically, right? So F, read lines. So notice different command, different method, a list of lines. So what's a line in a text file? How would you define a text line? Well, it is what comes at the end of the line. Yeah, slash n or new line. New line symbol, right? You can say carriage return sometimes, but of course, so this Python will do it for us. We don't have to split it. We could do split and read everything and split, but we will let Python handle it. Right. We can also, by the way, say how many lines to read, but usually we read everything. So this will be a list. Let's see how many lines do we get. Will it actually work? Then will it work? Hope it works. Okay, something didn't work. Okay, file pass. Okay, UTF-8 codec can't encode. This is something actually that happens, right? So there looks like the coding will need to actually, let me see if it has some weird encoding. Looks like there's some strange encoding issue. Can we do this ASCII? Okay, there is some bad code actually in this file, right? Position 303767. Actually, it usually looks like it's actually encoded by some other format. Looks like it's not UTF-8 apparently. Let me see what else could we fix. So this is actually, you have to figure out what it is actually, right? So we have to open as a binary file. Maybe it's not a movie lines. Well, we can of course open up here, right? We can check here. Too large. It's a huge file. Looks like maybe it's not you could download and see what is inside, right? You have to
movie title metadata.
Yeah, that looks like more handled. Is that JSON, not JSON? Okay, yeah, let's do that one. Let's copy this one. This is maybe copy pass, right? So I will file pass, right? It will be, this might be slightly easier to hopefully, you know, it could be some, I don't know, movie from Turkish movie, I don't know, Japanese movie, something which is not properly formatted. If you work with the data, I'm sure you encounter this situation. So this will be movie titles metadata. Let's try this now. Okay, another. So yes, this Cornell data set is something is not quite right. Let's take a look. Yeah, looks like something really weird here, right? That's what it looks like, right? So there's some fancy characters somewhere here, right? So this is not working. Let's figure some better example here. But this looks like really nice example. But apparently, this will be work fine. This is, I think, Alice. Let's check. I think this will work. Let's try this. I think this is Alice in Wonderland, or maybe some other book. Let's try this one. What's this? Artist's question. So let's go for try 3. Right.
Another try. You could try a different code.
It's a Windows. Yeah, that's what will be the next. My next. This looks like it's an old type from Windows, from 90s, 2000, early 2000s. So we'll try this first, right?
Russian characters, 1.52.
No, I think it's yes, Cornell's movie corpus. Let's try this. So this is actually good. Windows. 1252, right? Special case. Turns out that this Cornell corpus at University of Cornell, of course, corpus uses older encoding. But let's see if this works, right?
So it might not work.
Again, it's oldest reading, of course, Google. All right, so some people had the same problem that we have, right? Again, I don't remember when I did this. This is a long days that I did maybe a couple years ago. So again, so a little bit of dirty laundry here. So
does it work?
Okay, let's try it. Okay, one more time.
Okay.
Yes, it works. Yes, thank you, Uldis. Right, so this works. This is one of those cases. So encoding Again, this is the natural place to Python supported encodings. Supported encodings. Right, this might be useful for you. Right, codecs and basic class. This is I've had some students who do have some old Russian Soviet encodings. This is codec based classes. I think here, somewhere here. Maybe if you can put a link to it. I don't know if I can find it now. There are
Python supported encodings.
Yes, the UTF-8, right? CP, right? There are some really esoteric ones too. If you have it. So, okay, so we have movie titles. Okay, we have movie titles. Okay, we have 600. So read lines, right? Not UTF-8. So okay. So this is one of those cases. We have movie list. So let's look at what kind of movies are there. So let's say first 3 movies, right? Okay. Again, so this looks really fancy thing. So what do you think? If you wanted to create data for this, probably Pandas would be good. But what would be a separator here, right? Look at the separator. I see a nice separator here, right? It's I don't know why they chose this, but it's using 2+, $sign, true plus. This would be a nice separator, right? For units, right? For individuals. Yeah. So again, if you're working with data, you will encounter some strange things. I'm sure they had some good reason to use this type of. They figured no movie will have this type of text inside, right? So they use 3 pluses, $, and 3 pluses. Okay. Well, no problem. We can use that. So I think we can do it with Pandas, right? Let's do it with Pandas. I could use a split inside, but I'll use Pandas, right? So we have the address. So we have Pandas already, right? So df equals Pandas read CSV. I'll say it's a CSV file, right? And so file path, right? And separator, right? And we'll see if this works. Separator is equals this crazy thing. Right? This is we got a very interesting harder case and encoding. Let's see this also. We need also to specify encoding. This is a hard case. We'll see if this works out of the box. Encoding. Let's see if this works. I'll be df head. Let's see. Do all these things will work or not? What's your guess? I think it might. We might not.
Let's see.
No, it did not work. Nothing to repeat position 0. Okay, the separator thing looks like it did not. Maybe I skipped the. What happens if I did this without separator, right? I'll do $. Let's say I do $, right? It might not work at all. Oh, it worked actually, right? It worked, but you have all these pluses, right? So this kind of. So what I suspect. Pandas is using regular expressions, and plus has a meaning in regular expressions, so it doesn't like this separator. Right. So of course, what we could do is we could pre-process this, right? We could figure out, we could go through a huge file and replace all of these with some other symbol. So let's do that actually, right? We could do that, right? Let's do that my own. That's also part of your work is usually this data munging or data pre-processing. So let's do that. So for that I will read it whole movie, big file. So instead of this, instead of list, right? I will open up movie text, right? Read, right? Movie text, read, right? Read, right? Movie text, movie list. So len movie text, right? This is right. So that's all the symbols. So what we could do, as we remember from string operations, a clean text will be movie text replace, right? And let's do this whole thing. This shouldn't be. This I don't think regular expression should not take place, right? So we'll come up with something stranger, something. Well, comma would be. Again, movies might have comma. Let's figure out what we could use. $2 signs, $3 signs. I don't know. Okay, I figure out movies don't have $3 signs. Hopefully, what do you think? $4 signs, okay.
Why don't you replace it with a tab character?
Tab would be okay, but I'm worried maybe there's some tab there somewhere, maybe here. Okay, let's do tab. That would be better. That would be perfect. I'm a little worried about this. Okay, what we do first, of course, is why don't we movie before we replace? Let's do some research, right? Count tab, count tab, right? 0. Great. Okay, we are good to go. So we can replace it with a clean text. Now I want to save it. Okay, so where do I save it? And also I'll use this regular UTF-8 encoding at the same time. Let's see. So with open, I'll figure out. Let's see. Where do I want to save it? Do I want to save it in my Google Drive? I guess I could. Right? I'll do it in Google Drive. I could do in my current directory. I could do it. I'll just do it here. So clean, kernel clean, right? Since I'm lazy, I don't want to look at the map. Kernel clean, right? Text on kernel movies, maybe kernel movies. Text, right? So I need to say mode right? Mode right. And let's do encoding UTF-8. Let's see if this again. We'll go and we'll upgrade to modern as F, right? And then it's just simple F right, clean text. Right. Oops, sorry. Clean text. Come on, pick up. Here you go. And let's see if this works. Right, so this is standard recipe you might be useful to remember. Right, that's how you save something, how you write a text file in a unit with using UTF-8 encoding. Assuming you have a text, of course, right? So, no errors. So it should be where? It should be here, right?
Current directory.
Yeah, it should be, but I don't see it. Why don't I
refresh?
Yeah, so how about we refresh here? We just open refresh. Yes, there we go. There it is. Okay. So it's there, of course. Again, remember, if it's not in my drive, if it's here, it will go away, right? After I close this notebook. If you want to save it permanently, you have to save it in a drive directory somewhere, because that's my Google Drive. Okay, so now let's read the CSV. This kind of is ugly. So let's do it again. That was ugly. Let's do it again. So now file path will be kernel movies. Kernel movies text. And here we didn't have a header, right? This doesn't have a header, so we'll use this basically tab. And encoding is UTF-8, right? Okay, let's see if this works. Yeah, perfect. Looks like the first line, ignore, it looks like it picked the header, column names are from the first row. Probably not what we want, so we will need to add an extra command. Let's see, ignore, okay, thing is, if you index column, read CSV, as always, Pandas is a huge directory. This is where you go. Pandas CSV has a good help documentation, because CSV, look at this, there's about 50 different options for reading CSV. And again, this is not because Pandas just hates you, it's because CSV hates you, because CSV, because everybody has their own idea of what CSV should look like. There's no standard, right? Somebody uses commas, somebody uses a tab, somebody uses 3 pluses, $sign and 3 pluses, right? And somebody uses strings inside, different formats, right? So separator, header, okay, none. You want header none, right? By default, it tries to guess the header, right? Which is a good choice, I think, right? Tries to guess the header. Well, here we don't really have a header, right? So we don't really have a header, so header none, right? Header is none, right? Yeah, so now the columns are just basically numbers, right? We'll change the names. I don't know what these are. These are looks like some just right. This is just some database of some movies. And there is a nice little what should I call it? Themes or what you call. Topics, exactly, right? So this looks like this was using some machine learning project. It looks like, certainly, right? And of course it has IMDb ratings, probably year of release, right? And this is probably reviews or something like that. I imagine it's something like reviews. Yeah, it probably comes from IMDb, which is owned by Amazon now. So since we are nicely transferred the two or next topic reading Pandas. So I will add some columns. You want to change some column names, right? So I'll show you how to do that. DV columns, right, is boring, right? 0, 1, 2, 3, 4, 5, 6. So there's 6. So what you can do is basically come up with your own. For now, columns equals, let's see. So that's just a, I'll call it movie ID, for example, right? I don't know. Title, right? Release here. Release year. I don't know. I'm just rating, right? IMDb rating, right? Reviews. No, review count. And last but not least would be topics, right? Teams, I don't know, right? Something like that. 1, 2, 3, 4, 5, 6. So you have to be 6, right? So let's check. DF head or tail. Yeah. Okay, we have a nice little. Okay. So if you like this, right? By the way, at any point you can. Okay, you say, okay, I need to leave. You can save as PSC, but maybe you want something nicer. Maybe you want Excel. So no problem, right? It should work. Let's see. To Excel, right? You want to say to Excel, right? And I'll do this here. Say movies XLX, right? Something like this. It should work. Let's see. I think it should be enough. Let's see if this works.
So we are using Pandas library
as a converter. Yeah, you read some ugly old CSV file and you save it as a CSV as Excel file for later use. You made some columns, right? It looks like it works.
Okay.
Yeah.
Let's open it in Excel then.
Yeah, I have Excel as well here. Okay, so I have to open it. It's here, right? I could download. Let me download, of course. Right, I could download and I could open up Excel file. Right. Yeah, it's there, right? So you can work from Excel if you're not ready to do it everything in Python, of course. Usually do most of the work with Pandas, right? But again, if you need to, right, you can always save it. And again, Pandas supports multiple, so 2, right? 2. Right, 2. Come on, you picked up. It should be picking up again. 2. Come on. Slow. Okay, look at this. To CSV, to dictionary, to clipboard, to Excel, to further, HTML, NumPy, Markdown, Parquet, Pickle, Records, XML. Also should be also to Stata, which is statistics, SQL. So pretty much, you name it pretty much supports a really wide variety of formats. Same goes for reading. So Pandas can read and write wide variety of formats. Right. Okay. So, all right. So that's in pretty good shape, right? And yeah.
It's a question or?
It came from my old Google Drive. We found it. Yeah, but that's fine. But all this, maybe let's find this. Okay. Yes, that's a good idea. So why not find it? This is public information. I'm pretty sure. Can you find the link for this? So Cornell movies movie corpus, right? We got carried away a little bit, right? Your own Google Drive will have different contents, right? Yeah. So. It probably came from Kaggle, right? It probably came from Kaggle. I'm pretty sure I did it. That's also where our workshop from tomorrow also comes from Kaggle. Are you familiar with Kaggle? It's basically for data science, machine learning, the main, so to say, hub. So to say, where different data sets are found, different notebooks are found, right? Dialog corpus, rating, release. This is actually dialog. So let's see. Metadata rich, download 10 megabytes. We can see this. It's public domain, right? You can see this is the correct one. Yeah, Kaggle. You need, of course, it's owned by again. Not shockingly, Kaggle is owned by Google. They bought it like 5 years ago, right? So you need again. So this should work now. Let's see what this is. The movie characters, movie lines. I think it is. Yeah, it is. Right. Certainly looks like titles.
movie characters, metadata, movie lines,
Yeah.
movie conversations.
I'm trying to remember what did I read actually? What did I open up? What was
Share your own file,
Yeah.
Can you share your own file?
What do you mean? Oh yeah, I can.
On GitHub.
Of course. I'll do it. Yeah, sure. So I opened this is movie titles metadata. Yeah, movie titles metadata. So this is the address, right? So I will download it, right? And I will upload it then also, right? So no problem. Where was Google Call? No. My drive, my data. Let's say my drive. This you can find it. So drive, my drive, content, my drive, data. Oh, there we go. And then Cornell. So data, here we go. Right, Cornell. And movie titles metadata. This is pre download, right? I'll just download and I will upload. Here I'm gonna do it lazily. I'll go here to our collab. We have data directory, right? Corpora. It's not technically Corpora, but I guess I'll or notebooks. I guess I can add it here, right? Data, right here. I'll add it here. Okay, upload. Right, add file. And again, this is the quick and dirty way of doing it, right? Downloads right here. Movie titles and the data. And this will be interesting to see. Right. Commit charges. Right. Okay, it's there. So now we can get a link to it, right? If you want to do it by using web, right? You can do it. You can find here data. So this is maybe also you can post the movie titles this link for
so that's the raw format.
Yeah, that's the raw format. It will be interesting again. With formats as you will experience, sometimes this UTF-8 encoding might be added in the process of uploading. Maybe GitHub does something. That's a good question. Will it be still in this weird old Windows format, or maybe it will be UTF-8 already, right? Because all this certainly looks okay to you, right? So try maybe add this link. So this link is here, right?
Should I post the raw link?
Yeah, post the raw link, right? So people can upload using requests, right? So this would be. I can try it as well. Copy link address. No, I'll do here. Movie titles. Okay, raw. We want the raw. Right, that's a link, right? That's a link. And let's try it. See if we can upload it. And by the way, see Pandas can do it as well. Can read URL directly, which is really nice. It's a nice feature. So a nice feature. And let's try it here. So link URL, right? Of course, I need.
And I posted a link to the chat.
Yes. Okay, great. And let's try this reading. So I'll call df2, right? Pandas read CSV. This will be a good question. Will it work or not? URL. So instead of pass, URL, it's basically just a link to string to the address. And separator. What is a separator? Oh, that's a scary thing.
That will not.
Ooh, okay. This will fail, right? So we'll need to download this. We need to use the Quest first, right, to download it, right?
I'll try it, but you probably won't.
Yeah, because I'll try the $sign for now, right? And encoding, let's see, that's a good question about encoding. I'll use the Windows, right? Windows 1252, right? Ability was, right? Okay, let's try this. DF head, DF2 head, let's see what happens. It worked, right? We still have these pluses, right? I wonder there should be a way to turn off regex, I believe, right? We can try. This is probably so that works, right? It works, but we have those plus, right? So probably not right. It's kind of messing things up, right? So let's try it one more time. This is a harder case, right? So I suspect this won't work, but we'll try it. DF3, right? DF3.
Okay, there's a question.
So you need the link, basically. Right.
Yes,
Yeah, right click. You need to right click on it, basically. Right click. Yeah. Right click, and then you will download. So again, nothing to repeat. Right. This is a regex syntax. Again, same problem.
What if you put backslash in front of every?
Oh yes, probably. That's what you need to do. Right.
It might not work. But
Yeah. So that's. Yes.
looks funny, but it
Looks
might
funny. It might work. It worked, but not quite what we wanted, right?
Yeah.
So we have basically everything is just a single. Basically, each row is actually a single row. We don't have any cells, right? We just have a. Yeah. So it's a really, I would say, really non-functional spreadsheet, non-functional table. So maybe this one also be escape. Maybe. I don't know. I don't think so.
Well, try it.
We'll try one more. Yeah, it worked.
Wow.
Oh, wow. Okay. So if you have something that's strange, you can always, these are so-called escaping, right? You can do it directly. So this, of course, again, one thing I forgot is headers none, right? Header is equals none. Right? Let's do it one more time. Again, remember if you have URL, this actually makes a call to a web address, right? So it worked. Right. So quite nice actually. Okay. So this translates nicely. So we want to filter these things, right? And what can we do about this? When you have a table, right? So this DF, right? It's called data frame. Those who are taking parallel tag with R also know data frame. Data frame is basically a table, right? You have rows and columns, right? Columns have specific data types, right? And rows, of course, sometimes called records, right? You are basically represent one unit, one I would say, one unit of data.
Okay.
Yeah.
There's a question. Maybe before we go into data frames, maybe we should look at reading archive files. Just so
Yes. You probably maybe you can finish that here from what.
Okay.
Yes.
I can do that.
Because you will need that to complete your work actually. Your assignment.
So there's not that much left to show, but so the topic I wanted to mention is reading archived files. You will notice that the GitHub repository, its corporate directory contains zip files. So these are tab-separated values files, but they have been saved to save space. They have been saved as zip files, so archived files. This is how we read archived files. Actually, there's not much to it. Just again, there will be a version that works for local installation and doesn't work for Google Colab and the other way around. So first, let's look at the local version. So we define the file name, and then we use Pandas read CSV method, which you are familiar with already. But we add a parameter called compression. So we tell it that compression will be zip. And when I execute it, well, for those who run Python locally, for example in Anaconda, it will work and you will have this file read into data frame 2. In our case, we are using Google Colab, so that will not work. But here is a version that we can uncomment. So remove the comments from these lines, and we will read this file directly from the web, so from GitHub. So this is the URL to the raw content of this file, and again we define a URL, and then we tell Pandas read CSV method that we want to read a tab-separated file. So columns are separated by tab character, and compression is zip. Let's execute this method.
And I believe this method should work also for those on Anaconda. If you have problems with the file, finding a file on your computer, this should work, because this is also, it's a web address, so it should work for everybody.
Indeed. Yes. And let's look at the size of the corpus. So it has about 320,000 records, and it's reading quite fast. Let's look at last 10 entries. So tail 10, and there we have the corpus with language, source, date, and text. And Pandas supports a large number of different file formats. You can look at the link for information on what these formats are. For example, we could read Excel files using Pandas read Excel, and Valdis already showed how to save Excel files. So at the moment, we have time for question and answer session. If there are any questions and answers,
and then we'll proceed directly into filtering this data, because your task will be for today will be to filter a mini corpus from this bigger corpus you have. So we have three corpuses: Estonian, Latvian, Ukrainian, and maybe I noticed there is we have attendee from Finland, right? There should be a Finnish corpus as well. We don't have it here, but you could download from Kaggle actually. If somebody is already familiar with Kaggle, it's a possibility. So we are offering three corpuses to work, right? So Estonian, Latvian, Ukrainian, and so that's the link. So that would be something to read the file into using this what Valdis just showed, this read CSV, right? You just need the right. You saw the Latvian example. So if you have Ukrainian or Estonian corpus, you just have to change the address. That's all.
So shall
Excuse me? No, you don't have to understand the language, but of course it will be more interesting to filter things. You don't have to really understand the language directly, right? You could do some, let's take an opportunity to learn the language a little bit, right? If you do we'll do some searches for most frequent words, you'll probably figure out which words are important in that language, right?
All right.
Yes.
So should we switch to the next?
Yes, because it's going to be exactly the third one, opening a collab, right? Because we spend more time on basics, on the actual filtering. We'll not have that much time.
Okay, filtering, I guess let's.
Yes. I'll finish this. Right. So we already have. So we can read this. We can read this file, right? Hopefully everybody is able to read it. So we'll go to the third notebook on how to filter it, right? So we have a corpus, we saw 5,000, I mean we had 300 something, and we really want to have a smaller corpus, like for example how old this has a smaller corpus, we'll make it even smaller, right? Again, we'll use it, this is a new notebook, right? Filtering documents with Pandas, the third one. It's basically continuous where we left off, basically. So we need, of course, this new notebook. It has no memory of this previous notebook, right? So I need to load the data again, right? So connection, right? So we read this CSV, right? The address. Again, if this was zip, we would add a compression equals zip, right? It's like this, right? Yeah. Parameter, right? What else is there? URL separator. Yeah, that's it. Okay. So the shape we see what it looks like. Head is basically the first 5 entries. Yeah, I'm showing the Latvian example, right? Again, you don't have to understand Latvian to understand what's going on. So we have language, source, date, text. So let's check how many different languages are in this corpus, right? You're going to check this column, right? So unique. So Latvian, only Latvian. Okay, that looks like the right corpus for this particular purpose, right? So how about sources, right? We have a source. How many different sources we have for this corpus, right? It's just a column, right? So df source. So this is a column name. So source. So language is the name of the column, right? I should mention, right? If column names are you use spaces, you need to use different full syntax, right? I'm using the short syntax, df language, right? It's like looks like a dictionary, language unique, right? This is also right. So of course, again, programmers are lazy. You don't like type these extra brackets, right? So this is the same thing, same as above, but will work with spaces, right? Because if you have a column name with some spaces right here, it will work, right? Okay. Also, if your column is named maybe some popular, has a Python keyword or Pandas keyword, it will also work. So, source unique. Look at this here. So this column has these sources, right? You can find the source. So how would I filter by particular source? Well, so that's your Pandas recipe is to filter by use this. So basically, you say you want a sub. You are filtering. You are creating a view actually, right? A view, right? Which is a subset. View. Data frame. Technically, a view. From original data frame, right? Which is subset, right? So you're saying go through and check if only find those rows which have a source DNLV. DNLV is Latvian newspaper, right? So these are all either actually these are all websites, right? Of course, scraped from websites, right? In like 15 years ago, right? So and we have out of those 5,000, we have 600 articles from DNLV, right? Okay. Let's see how many. Let's double check. Well, it should be only one, right? We should double check if it's really the case. Yeah, it is. It's only one, so it works. The filter works. So obviously, this filter, right? You can filter a particular newspaper or a particular source, right? So again, we can see. Right. There's some looks like different dates. We have a date column. We have a text, right? And this is actually what we will want to know. So, by the way, if you want, if you are done, you say, okay, I don't need any more filtering. How do I get this text out, right? Well, it's a text column, right? And I want to get it in a something. Sorry. Again, escape B. Come on, not picking up. Escape B. Now, okay. Right. So I want to get columns. So documents, right? Document list, right? B. DF, right? Text. I can basically do list. Right? I can do this. The list also works, right? So len document list. 634, right? Because that makes sense. 634, right? We have 634 rows. Obviously, we don't have the. We know it's from Diana. We don't have the date. We don't have the date here. But so now they are. Let's check out first 3 documents, right? Document list. Right. Yeah. So the first one is just an email, apparently, right? Second is like a title. This actually is real article or part of the article. Again, this was done by none. The person who did the scraping, I think he was from Hungary or somebody, or from Sweden. I don't know. Right. So there's no extra. The curation has not been done on this corpus, right? So we have a list of strings. On how would we save this on a text file, right? You want to save this as a text file? We could save it as text, right? How would you do this? Right? We could also this open, right? I could save it, just text DN docs, right? Text, right? Mode equals right? There might be also Pandas method. This is encoding UTF-8 because of course this is Latvian, so we want right as if. And a good question is what do we want to as if, right? So we could do basically we'll want to do this. We could do read line, write lines. If write lines would work, right? This would work, right? Document list, right? But this will write without new lines, right? So one big string, right? Not probably what we want. Right? Probably not what we want. Let's try this, right? Right, it worked. The docs, you see, it's a new notebook, so we have no other data here. Let's open it up. You see, it's just one big, only one entry, right? One big string, right? Probably not what you want, but it might be what you want if you want to do some analysis on this corpus, right? It might be okay. But the problem is, of course, that one text, one line ends, you don't have a separator at all, right? In the next line, the two words will be together, right? Probably not what you want, right? So, how would we fix it? We can do this, right? Join, we can do this basically, add. So this is, I'll skip this, I will do this, F right lines, and I'll do this, new line, join, document list. Right, this will be better, right? So each document separated by new line, That will be probably much better. Let me open tab again. And of course I can download if I want. Yeah, look at this. This is nice, right? This is basically each of these documents get its own line, right? So probably something like that. If you want to save it. Okay, as a text file, basically, right? So I'll close it. Right. So let's do some more data munging. So date. We have object. Info in Pandas gives you your data. So object here means object means string here, right? Basically, and we want to probably do some. Wouldn't be nice if you have a year. How about this? Couldn't we make a year column? Right? Would be nice. So how about this? I can make a new column of current year. Maybe not very useful. Right? By the way, it tells you that it's actually we're using it on a subset, right, on a slice of data frame. We don't have the full corpus, we only have slice. You don't have to worry about right now. So current year, everybody gets current year. Okay, so that's nice, right? We made a new column, right? But it's not good for our filtering, right? So what we could do is we could split. Let's look at this date, right? You have date. How do we get the year out here? Or friend split, right? Pandas also has a built-in split, which we can use. What can we split? We use a forward slash, right? Forward slash. We'll use that as a splitter. And let's try this. So we're saying we want to split the date column and split and keep the first part, right? And that's going to be our new column. So we create a new column here, right? And we split and we get a year, right? It gives you warning because it's subslice, so year 2012. It's new column, right? So we can use that, right? That's nice, but the only thing is, of course, is that it's still a year, right? It's an object, it's a string. How about let's check the distribution of how many different years we have in our corpus, on this mini corpus. So we can use the value counts. Okay, 2011, so this is relatively old corpus. 2011 is 442. Right. Okay. So how about let's get year 2011, right? So how would you do it? Diana 2011, that's the name you come up with, that's up to you. On we filter by this number, right? Notice something we're using is still a string, right? It's still a string, right? This is still a string, so it might not be good, right? So this is only 2011, right? Year 2011. Well, let's take a look at the info. Current year is an integer because we did it by hand, 2022, but everything else is still an object. So how would we make a year an integer? Well, we do it as follows. If you're pretty sure this is actually a number, right? You need to convert to a number. You say create a new column, right? We come up with so we're going to create a new name for the column, year numeric, and we take the existing year column and try to convert it to integer. And here it should work. Let's see. Right, on. Let's take a look. So what's different? Why did I do this? What is year and year numeric? So year is actually a string, right? These are year strings. So year numeric is actually an integer. So where would this be important? If I'm going to do filters, if you do string comparisons, right? They don't always work exactly the same as numeric comparisons, right? If you have sometimes you do divide like 99, 9 might be bigger, string 9 will be bigger than 20, right? I'll show you an example, right? Why is this important? Ah, come on, it's not picking up my... Okay, here you go. So why string, why numbers, my integers over strings, from strings is because of this. So if you have a 9 larger than 20, right? True, right? This might not be what you want, right? Why did this work? So because 9 beats 2, right? And that's not what we want, right? And then there's the 0. So what we wanted this. This, right? 9 over 20, right? That's why I'm doing this data. So dealing with data, you usually want to convert numeric data to numbers, right? So let's check. Again, let's check our info. I'm gonna close this. Yeah. So we have integer. That's good. Right, we have a columns, right, again. So let's get years 2000 to 11. Right, so now we know we're going to use numeric. We're going to use numeric. We could have used the year string, and in this case I think it would work exactly correctly as well, right? Because we have four digits. I mean, if we have 4 symbols, it probably work, right? But better safe than sorry, so we're using convert to integer first. So how do I filter? We're basically using two filters here. So first I take larger, and then I take larger more than equal to 2009, and less or equal to 2011, right? Afterwards, so square brackets. There is other syntax. I'm not showing you here. It's a little bit more difficult. You can use it as well. There's a link here if you want to use the other syntax. Let's check how did this work. So if this syntax works correctly, we should have 3 years, right? Yes, it worked. 2011, 2010, 2009. Excellent. Okay, so this was filtering by some numeric, larger or lesser. But we probably also, since we are doing research on text, we probably want to do text, right? Filter by some text, right? So, how to do this? We have a text column, right? Text, right? So we need to add string, and then we use contains, right? A filter. So diriga. So out of this DNS 600, we had about 600. We're going to take only those articles which mention Riga, right? 70, right? So there's also a sample. If you want a random sample, not just take all 37, you can check. Just gives you a random sample, 5. Right, so some 5 random. If I keep running it, it should be random each time different, right? Yeah, random sample, each time something different, right? Of course, we only have 37 entries, so not much different still, right? So we have it works. And again, how do I get text out? If you want this first article, so we go there, Riga text, right? We convert it to a list, right? And get the first article. So text of first article in our sub corpus, right? Yeah. Something about Cirque du Soleil looks like something they were visiting in Riga. Okay. So this is a contains, right? Contains some keywords. There's a question? No. Okay, we are almost done. So you can those are familiar with regular expressions. 1, 2, good. Okay. Somebody else? Okay, so 2. But okay, so this is if you need some more stronger way of searching. So Pandas, actually Python 2, this supports regular expressions. So if you need to practice, right, there is a site, of course there are many other sites. You basically can enter, you can practice here your regular expressions. So Pandas takes, you can modify this. So for example, using this regular expression syntax, you can say, okay, I want to check for Riga, right? Notice the capital E, right? The long E, right? And I want the different declinations, right? Declinations, right? In Latvian you change the nouns, right? So I'm sure Estonians as well are aware of this, right? So you want different endings, right? So you want A, long A or U, right? So you find all these 3 variations, right? So and of course there's wildcard searches, all kinds of things like that. So you're saying, okay, I want these, so this will pick up 40. Okay, so 3 more, right? Because it picks up this Riga and also Riga and Rigu, right? That's good. How about this? How about we want to get only those who are not related to sports? We don't care about sports apparently, right? So we want, so notice this little thing. So you say does not contain. So this is negation. Negation, you say I don't want these search terms. So and again, you can always filter, you know, keep making up new data frames if you're not sure if you want to keep using the old one, right? So I'm using this Riga 40. And let's see how many articles I have left. Probably like, I don't know, 39, I don't remember. Let's take a look, maybe 3. So we lost 3 articles, we up back to 37. Okay, so we have D Riga 2, D Riga 3, and we have also D Riga, right? We have 3. Well, they're very similar, right? But let's imagine they're actually quite different. Okay, what we can do is, how do we combine them? See, we have multiple topics we search for, we have multiple data frames we want to combine, right? So how do we do this? Use Pandas, concatenate, and then you write a list. This is a list of data frames. So let's do D Riga. Let's add one more. D Riga 3, right? And we are ignoring index because index is not meaningful here. We'll need to make new index. Let's see what the shape is. 114. However, right, we get now, right? But this is going to include some duplicates, right? I'm sure there will be duplicates, right? Combine ahead, right? We won't see them, but right. But most, because we are doing these similar queries, again, how do we drop duplicates? Could be useful after combining these data frames. We don't want, we want only unique rows, right? So we drop. We only keep one of all the duplicates. We only keep one, right? So basically, df unique rows, new data frame. We use the drop duplicates method, and we should have back 40, right? That's the max, because the rest of them are just basically duplicates. Okay. And finally, we can do maybe we want to organize them a little bit. And of course, you can do this in Excel or somewhere else. We can organize by, let's say, date. So we can sort values by date, ascending through, because we want a growing order of growing, right? From all the eldest to the newest, right? So, and we have nice data frame results, right? Starting from 2009, right? Source, the single source we had. So we filtered by source, we filtered by date, and we also filtered by some text. So these are all. So what will happen? So from Diana, specific source, text includes some mention of Riga with some different forms of Riga, and it's also was 2009 to 2011. So 3, 4, 5, I think 5 different filters applied. Plus we dropped the duplicates. Okay. So that now we have it. We want to probably save. Let's do save to CSV. Right. Sorted it. Right. We're going to use TS again. We could call it TSV if you want. Technically, it's TSV, right? Again, TSV or CSV. It's still actually just text file, right? Underneath, right? So I'll use separate T, right? And no, if you are running locally, you have the file. However, if you are running on a Google Colab, so what do you need to do? You need to download the results, right? So this will be your task actually today, your homework, right? If you want to get the credit, so you will need to do something very similar to what we did just now. So here is the result, right? And download. Right, and that's something you will submit, right? This is the CSV file, right? And so what's your task? So yes, since if you don't want credit for this course, of course you will need to have tasks. So open up the zip, one of those zip files in your language as a starting point. And then I want you to filter corpus so you have at least 100 rows. Again, so maybe some instant keyword matching, right? And save the corpus as this. However, I would like to see a different name than Riga, right? You know, make it meaningful, right? Maybe it's from, I don't know, place Tallinn, maybe Kiev, maybe something else, right? Some other topic maybe, because these corpus are big. They have about at least 300,000 articles. So there should be plenty of room for improvisation.
There's a question.
Yes.
Could you just short describe your corpus, because I don't understand any of these languages.
Okay, so you can search by, of course, by year. So these are newspaper articles from 2006 to 2012, roughly, right? From different online sources, right? So what you can do is, of course, search for some words which you think might be there, right? Contains, like I showed you in this example, search for some keywords, basically. That would be probably I would recommend, right? So open up. Let's see here. So how do you submit it? There's submission form. Let's see what happens. Actually, if all this goes there, click all this. I'll click it too. I'll have my own, right. So you need to enter your name, right? Your email, right? It's not going to be used anywhere else, and you add these two files. So what do I want to see? I want to see the same. Download this notebook, right? And it's the CSV file, right? Yeah. So the only thing is submit only the first 100 rows. How would you do that? Let's say you have a big corpus, right? And you filtered something already. Let's see. Let's look at. Yeah, a few more. We'll actually finish, but we'll finish. So we have our DNA, right? I'll show you here. So DNA, right? DF, right? Shape, right? Is 600, right? So you could do this basically. Head, right? DNA 100, right? You could do this basically, right? DNA 100. You could do sample. Let's do sample, right? You could do sample, right? DNA 100 is equals DNA DF sample 100, right? DNA 100 shape. Yeah. So 100. This is one way of doing sample. Could use head, right? Or tail. Or tail 100. But I don't want again for full credit. Don't just use head or use this single command. I want right. So this is actually from our organizers. There's a question about this. I want to see some filtering beforehand. Right? So if it's just the first 100 entries, it will not be very good, right? So DNA 100 shape, right? And you can save it now, right? You can save it. So Pandas to CSV, right? DNA 100, right? CSV, right? And this would work. Let's try it. Sorry, it's data frame. Yeah. Yeah. It's saved, it's here, right? So you want to download it. If you're on call, if you're locally, you already have it. You upload, and then this is what you would upload to this for this assignment, right? So again, your corpus, if you filter something for more work, might be larger, but submit only the first row, because there's a limit of 10 megabytes if you are going to submit 100,000 rows, right? Since I already have them, right? So just save some space, right? So add two files, right? So your notebook is basically, so your notebook you submit here, so you submit this same notebook just with your code below. Right. That's basically add some new cells, right? On keyboard. So what I will do is I will add this to GitHub. So these new changes just work, right? These examples, add a few more examples. I'll add it to GitHub. Session 3. Let's say for authorization. Okay, it should be ready. If you go to GitHub, it's been updated. And by the way, on GitHub you can read, you can look, see the notebook, but you can't run it, right? It runs on column, right? This is not live. GitHub just shows you the notebook, right, as a web page, but there's no live interactivity, right? You can see all the instructions, right? Everything is visible, all the stuff is done right here, right? Is the link here? Yeah, link works here. Yeah, everything works. Okay. All right, so tomorrow we will work with NLTK, which is a natural language library. We'll look at also costly visualizations, and maybe we'll get to also topic modeling for exploring different topics in these articles. I know it's a lot of cover today, so and also it's during the third session, of course, we're all getting tired. So any questions? So basically this name is not required. Actually, I should say you can rename it if you want. Basically, it's this you submit, like I mentioned here. It's basically this file here. Filtering documents with Pandas is fine. Because I will see in a spreadsheet, I'll see who submitted what, basically, right? So you don't have to worry too much about renaming, right? If you know how to rename it, that's great, right? But it could be filtering documents with Pandas is fine, right? Submit the same notebook. You basically you do the work and save it. Well, if you only if you're an Anaconda, you already have it saved locally. So you basically upload the notebook you worked on. The same one, filtering documents with Pandas. Just with your extra cells. Some few more cells here. Yes. So filter according to your ID. Again, it could be just by year, but probably maybe something more interesting. Maybe filter by some name. That's what I want to see.
Are there any more questions for participants who participate online? Let us know if you have them. If not,
we'll see what time tomorrow we start.
I have to check. Tomorrow it's at 1:20.
1:20, kind of late, right?
Yes.
But it's going to be only very short breaks. For some reason, there's no break between second and third session. That's going to be rough, but okay, we'll do it tomorrow. So it's been a pleasure. So if you have any questions, again, tomorrow we'll go through them. What's the deadline for date? When is it due, the assignments, actually?
I don't know that.
We'll ask. I imagine you don't have to, not tonight, I believe, right? So
hopefully not.
Hopefully not, right?
Well, we can check with
yeah, we'll check with our organizer and see when it's due. Because
there is a question from Konstantin. And there's a question from Evgeny. Evgenia,
Maybe leave it open. We'll ask Anda. We'll ask. We have a few minutes. I'll check.
about deadline, okay, so we'll check that. And Konstantin asks, do we need to register somewhere to work with National Library?
Well, if you need some data from National Library, yeah, you need to write to DHL, LNBLV, I guess, right? So that's good. But basically, with Latvia, the answer would be that there are many corpuses already available from National Library, right? If you need a specific set, yes, you need to register. So yes, notice how the earlier notebook has been disconnected because I was not using it. So Google said, okay, you need to stop using it because we are going to close it for you.
So you're saying that many corpora from the National Library are already available?
Well, there are many available, right? But it depends what you want, right? So if you need something specific, you need to contact, yeah. So, the main page, right? Yeah. Email dh@lnb.lv, I believe, yes.
Okay.
Yeah. Okay, I'll close this.